Hello everyone, I'm Mrs. Rishali Chaudhary. Welcome to the Praveen Patil College of Diploma Engineering Technology. We are going to learn basic science chemistry for semester 1. Chapter 2 Metal Corrosion, its prevention, electrochemistry. Learning outcome of today's videos is to study galvanic corrosion, pitting corrosion and differential aeration. How this type of corrosion occurs and what is effect in industrial engineering that we are going to learn in this topic. Galvanic corrosion. Before starting with the galvanic corrosion, we have to understand galvanic series. This is a reactivity series of a metals. When metals are contact with another metal, they will form cathode and anode in presence of a liquid medium. Which metal will form cathode or which metal will form anode, that determines the galvanic series. It is a reactivity series or the electrode potential series. The metals at the bottom of the series are highly more reactive metal, tend to become anode. Metals at the top of the series are inert metal, stable metal, are become cathodic. When platinum and lead will contact with each other, as per the activity series, lead at the bottom of the series and the platinum is top of the series. Due to that, platinum will act as cathode, lead will act as anode. Lead will undergo corrosion. But when we are considering zinc and iron metal in contact with each other, so as per the activity series, zinc is bottom of the series and iron is top of the series. So iron will act as cathode, zinc will act as anode, corrosion of zinc will take place. So position of metal in a galvanic series determine corrosion. Galvanic corrosion. In electropotential series, nobility of metals determine. When two metals are in contact with the electrolyte or the liquid metal, the less noble metal will undergo corrosion. That corrosion is called as galvanic corrosion. The rate of corrosion is determined by the electrolyte, the difference in the nobility, that is a position in electrochemical series, and the relative area of anode and cathode exposed to the electrolyte. The difference can be measured as a difference in the voltage potential. The less noble metal will act as a anode and undergoes corrosion, forming a galvanic cell. Galvanic corrosion. Dissimilar metals and alloys have a different electrode potential. When these two are contact with electrolyte or any liquid medium or humidity, the metal having lower position will act as anode, another will act as cathode. If the electrolyte contains only one metal at ions, it is not easily reduced. The electropotential difference between the reactions at the two electrodes is the driving force for an accelerated attack on an anode metal, which dissolve into the electrolyte. So the anode metal undergoes corrosion more quickly and cathode will remain as it is. Corrosion of cathode will not take place. See here, aluminum, copper, both metals are contact with each other. As per the galvanic series, aluminum is having bottom position or it is a more reactive, copper is less reactive, noble metal. So copper will become cathode, aluminum will become anode. Anode will undergo loss of electron and degradation of anode will take place, while the cathode will remain as it is. The presence of an electrolyte and the electrical conducting path between the metals is required for galvanic corrosion. It is always referred as a dissimilar metal corrosions. Next type is pitting corrosion. Pitting corrosion is a localized phenomena obtained on a smaller areas. Formation of micropits is very damaging to the structure. What is meaning of micropit? Forming a small cavities, small holes, that is called as micropits. Pitting factors can be used to evaluate dangerousness or the severity of pitting corrosion, which is usually observed in passive metals and alloy. Concentration cell involving oxygen gradient or ion gradient can initiate pitting through generation of anodic and cathodic areas. Chloride ions are damaging to the passive films and can make pit formation autocatalytic. Itself, whatever the corrosion take place, that is increases the rate of corrosion, that is called as autocatalytic. Here this is a pipeline. Here we will observe how the pits formation take place initially. As the time goes on, it is forming a small holes, and after that it is going to damage the whole pipeline. That's why pitting corrosion is more dangerous. It is going to damage the whole structure very fast. It is similar in a chemistry to crevice corrosion, except it happens in pits. Occurs in pits of metal surface where again electrolyte is aggressive. More of a problem of stringent solution. Very destructive since highly localized. May go undetected until failure attacks. Gravity causes pit to grow downward. Corrosion rate can be increased with time. Initially small pits are there, just like a cavity. As the time goes on, it is going to damage the whole structure. Next topic is differential aeration. What is meaning of differential aeration? Different air concentration. It's called as differential aeration. When same metal exposed to the different air concentration, it is called as differential aeration. The metal which is in an environment where the less oxygen is present, that part of metal will become anode and undergoes corrosion. Highly oxygenated part will act as cathode, remain as it is. Here we can see one metallic rod is there. Half portion is buried underground, so it is a less contact of a metal with oxygen. So that portion is called as less oxygenated. Upper part, it's a highly oxygenated, become a cathode. So at anode, less oxygenated area, metal is going to lose electron to form a cation. At the cathode, it will remain as it is, going to evolve OH minus. This is observed for the underground pipelines, certain joint crevices and cracks. Metals that are partially submerged in water are also subject to differential aeration. Just like a ship, half portion or the hull of a ship will contact with water, upper part will contact with air. So lower part, which is contact with water is less oxygenated, so that will act as anode and corrosion will take place. We are going to solve MCQ based on this. Pitting corrosion is due to breaking of oxide layer on the metal, acidity, stress in the metal, all of the above. The answer is acidity. Differential aeration. Corrosion takes place due to difference in the air concentration, difference in the air and humidity concentration, hydrogen evolution, oxygen absorption. Question itself shows that differential aeration, difference in air concentration. Answer is A, difference in air concentration. In waterline corrosion, the maximum amount of corrosion take place is. What is meaning of the waterline corrosion? It's a differential type of corrosion. Same metal exposed to the different environment. Just consider a ship. The bottom portion is exposed to the water, upper portion exposed to the air. So bottom portion is having less oxygenated, so it is going to act as an anode. Upper portion is highly contact with the oxygen or air, so that is a become cathode. As per the differential aeration, the area which is less oxygenated become anode and undergoes corrosion. So ship portion which is below the water meniscus having less oxygen contact, so become anode and corrosion will take place. Options are along the line just above the level of water meniscus, along the line at the level of water meniscus, along the line just below the level of water meniscus, the bottom of the vessel. It is option is C, because that portion will act having a different concentration of air and it become anode compared to the bottom of the vessel undergoes corrosion rapidly. Thank you for your attention. If you have any question, doubts, you can ask me. See this video twice, or you can ask me on my email address rushalic2111@gmail.com. Thank you so much for your kind attentions.